Hello, calculus students. We at Let's Unbound have created a dedicated playlist for AP Calculus AB 2024 free response questions. Each video breakdowns one FRQ with clear step-by-step solutions to help you understand the concept and scoring strategy. If you're preparing for AP exams or just want to review past papers, this is for you. So subscribe to the channel, bookmark the playlist, don't forget to share it with your friends. Let's make AP Calculus easier together. Let's start. So this is the first question, and yes, you know, first part is with calculator. So we can use TI instrument or decimals. So first question is this calculus based, of course. Table values of a function is given. The basic function is temperature of a coffee in a cup at a time t minutes is modeled by decreasing differentiable function C. C of t is measured in degrees Celsius. And for 0 to 12, selected values are given here. Then we need to solve the four. So we're going to break down with each subpart. Let's go with the first one. Approximate C dash of 5 using the average rate of change of C over the interval 3 to 7. Show the work that leads to your answer and include unit of measure. Right? So average rate of change is the basic average rate of change is slope formula for a secant line. Right? So C dash of 5 can be written as apply the slope formula where your 5 falls between. Your 5 falls this interval, so we're going to pick 3 and 7 as they have given. So slope formula is C of 5 minus C of 3 divided by 5 minus, C of 7, right? We are calculating for this. So C of 7 minus C of 3 divided by 7 minus 3. So what is C of 7? From the table, 69. Minus C of 3, 85. Divided by 7 minus 3 is 4. And subtracting and dividing this using calculator, you can do that simple, which is negative 4. And the numerator is degree Celsius divided by denominator is time that is measured in minutes. So degree Celsius per minute. That's simple. The first part is. So this is approximation of C dash of 5 using the table values. Very simple. Let's move to next. Use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the value of integral 0 to 12 C of t dt. And also interpret the meaning of 1 over 12 integral 0 to 12 C of t dt in the context of the problem. Okay. So how will you evaluate or approximate integral 0 to 12 C of t dt from the graph and using left Riemann sum? So let's have a quick review. So if this is your graph and you're going to do 0 to 12, integral means you will break down this into rectangles and you will calculate area of each rectangle. Right? But left Riemann sum means your height will be the left one. So this is actually what I did is right Riemann sum. So left Riemann sum, you have to complete the rectangle by this from your left side. So your left side point will be counted for calculating the length of the rectangle or height. Okay. So, but this time they're asking only 3 subintervals. So let's do 0 to 12 means 0 to 3, then 3 to 7. So they are not uniform, but this is how we're going to do. So 0 to 3, one rectangle we need to make. And then 3 to 7, you need to make a rectangle. Then 7 to 12, you need to make a rectangle. Right? So let's start solving this. So first is 0 to 3. 0 to 3, this is the width, which is 3. Height, which side you will take? This side you need to take because left Riemann side. So you just do C of 0. So 3 minus 0 times C of 0. First rectangle plus the next width is 7 minus 3 this gap times C of 3. Okay. Times C of 3. Then plus next is 12 minus 7 times C of 7. Because it's left right one side, I consider this points for height. So 3 times C of 0 from the table 100. 7 minus 3 is 4 times C of 3 is 85. Plus 12 minus 7 is 5 times C of 7 is 69. And basic arithmetics here. So this is 300 plus 340 plus 345 equal to 985. So this is the way we evaluate integral 0 to 12 C of t dt using the table of values. This is just an approximation. And interpret the meaning of 1 over till 0 to 12 C of t dt in the context of the problem. So 1 over 12 integral 0 to 12 C of t dt means this says it's similar to mean value, right? So this is sum of all the area below that. Right? We are adding up, summing up the integration and dividing by the number of the length of the interval. So this is nothing but mean means what? This is mean. You can relate it to mean formula. Sum by number of observation. Right? So you can, but in this context, we can say it's average temperature. Mean temperature will not that be good. So you can say average temperature of the coffee over the from time t equal to 0 to 12, we are calculating the average temperature. Okay, hope it might be clear. 0 to 12. This is the meaning of this particular integral. Right, moving on to next. For 12 to 20, the rate of change of temperature of the coffee is modeled by C dash of T. This is a function where C dash of T is measured in degrees Celsius per minute. Find the temperature of the coffee at time T equal to 20. They have given a C dash function, the rate of change of the coffee. We need to find C of 20. Temperature of the coffee, C of 20. Yes. How can we do? We will apply fundamental theorem and we will use Desmos also here. Integral, so we are solving in this thing, right? So integral 12 to 20, the rate function will be equal to antiderivative of C dash of T is C of T. C of T 12 to 20. And when you break down this, so upper limit minus lower limit, C of 20 minus C of 12. So integral 12 to 20 C dash of T dt. So from this you can get C of 20 is equal to, if you take it over here, C of 12 plus integral 12 to 20 C dash of T dt. C of 12, I have it from table of values 55. This one, I know C dash of T, and you can integrate it, this definite integral. So we're going to continue this here. C of 20 equal to, what is C of 12? 55. Plus integral 12 to 20 C dash of T dt. This I'm going to do it with Desmos. Right? So let's do, let me share the Desmos screen to you. Okay, how can we do it with Desmos? So inside the function, so integral, we are doing it from 12 to 20, not 0 to 12, okay? Then C dash of T, which is given as negative 24.55 e power 0.01. That parameter is T, here we will use X. Okay, so just understand the convention and Tx. That's it, we got this value. Okay, so negative 14.6708, and we're gonna use this in our calculation. Wait a minute. So here we go. So this one we can apply this. So 55 minus 14.6708 approximately. So this will be equal to 55 minus 14. 55, let me see. And is 14.6708 is 40.3292 approximately. So C of 20 is approximately 40.3292. What does it mean? If they ask for interpretation, we can mention. But still, this is temperature of the coffee. Temperature of the coffee is approximately 40.3292 degrees Celsius at time t equal to 20 minutes. At 20 minutes, this is how the temperature is. Right? Simple. Last part. For the model defined in part C, it can be shown that C double dash of T is this. For 12 to 20, determine whether the temperature of the coffee is changing at decreasing rate or at an increasing rate. Okay. So we understand the coffee is decreasing, right? The rate, how fast it is decreasing. Like, is it decreasing like very fastly or very slowly? That is what we're gonna do. How the rate is changing. The temperature of the coffee is changing. The change is changing in which way? How the rate is changing is the question. So we need to check the sign of C dash. So I hope you might remember. So if velocity is positive, acceleration is positive. So we will say speeding up, or so like double dash, speeding up or slowing down. Same process. Let's do. Sign of C double dash of T, we're going to analyze only in the interval 12 to 20. Okay. So 0.2455, it's positive, right? It's a positive number. So positive times e power 0.01t. When your t is 12 to 20, e power, this is anyways, it's going to be positive. It's not. This is also always positive. Then 100 minus t is also always positive because my 12 is less than 100, right? So it is going to be positive. So numerator is completely positive divided by denominator is t square. T square number is always positive. So in the interval, everything will be positive. So C double dash of t is always positive. So there is no negative. It's greater than 0 for 12 to 20. Right? So now we got C double dash of t is greater than 0. What can you say about the temperature of the coffee? Temperature, this is, so C dash of t. C dash of t, the rate of change of temperature is increasing. If your C double dash is less than 0, then C dash is decreasing. So this is the case. Now C dash of t is increasing. In context of the problem, we can write it like temperature C of t is increasing. The temperature of the coffee is increasing. Temperature of coffee, it's not increasing actually, is decreasing. Of course, we know it's getting reduced. Is changing at what rate? At increasing rate. Changing at increasing rate. The rate of change of temperature change is increasing. Okay. So don't confuse with that. Temperature is of course decreasing. They clearly state it's a decreasing function. But the rate, how it is changing, is in an increasing rate because of this, right? And this is all about the first FRQ from AP Calculus AB 2024 paper. I hope this video might be helpful and to you. So if yes, you can share it with your friends, and also you can save this for a reference. Save this playlist and also subscribe us and learn with us. Thank you so much for joining and watching today. Let's meet with second FRQ very soon. Until then, keep learning.